we are trying to build something which is quite compact. Unlike a chemical battery, which is usually installed in scattered areas in containers, we can stack up our unit. So in, let's say, a footprint of 15 by 15 meters and up to 20 or so meters, we can go to 500 megawatt hour storage capacity. And then you will have some 3-4 containers, 40-foot containers for electrical equipment, but not something which takes a lot of space.
Welcome back to the Decarb Connect podcast, and I'm really pleased to be joined today by Doron Brenmiller, who is Chief Business Officer of Brenmiller, eponymously named business, developers of carbon-free thermal storage. And we're going to have sort of two different aspects to our conversation. One is clearly about the applications for thermal storage, particularly as it gets into the higher levels of industrial heat, which is where our audience is mostly sitting. But we're also going to get Doron's, I guess, your feedback really on what it's been like trying to tap into the EU Green Industrial Plan, because I think it'll be interesting for people to hear really what's a working experience of that been. But first of all, hello, and would you like to just give it a little bit of more of an intro to you and your background in the business?
Yeah, so first of all, it's great to be here. Thank you for having me. I'm the Chief Business Officer of Brenmiller Energy. I was actually also one of the co-founders of Brenmiller when we started the company back in 2012. Our team comes from a lot of experience of solar thermal, being in the past part of companies named Solel and then Siemens CSP. And I joined this team together with my father and my brother in 2012 when we formed this company with the leading team coming from that experience. I'm coming from a background of electrical engineering and an MBA, and I took on the role of managing all the commercial activities of the company. So from the beginning up until where we are today, building partnerships, commercializing the technology, and I keep on doing that today in the company.
Thanks for that. And always interesting for me, certainly, is to hear like, how did you come to this kind of area of work? So I get, you've got this electrical engineering background, you've got your MBA, but you could apply that in any number of areas. So what was it about this particular area that sort of really drew you in? How did that decision come about?
So actually, I was born and raised on these type of topics. My father has been in this field since the 80s. So it didn't really start after I studied something or after the university training. It really started when I was growing up, understanding what could be developed, what could be implemented to make this world, a cleaner world. So I took it from the house when I was very, very young, and then grew into it and realized it's something I'm very passionate about as I continued on in my career. And up until today, I think it's an exciting field to be, and it's growing, it's evolving. And we really took this, I think, unique niche of being thermal energy storage. We're actually, I think, one of the very few companies who really worked on this field in 2012. Today, there are more. But I think we are one of the pioneers to come to thermal storage or to the energy storage field from this direction of thermal energy storage and not chemical, as we see other types that are more known maybe to the general population. So this is where we come from and where we are today.
I just want to take this opportunity to thank our production partner and sponsor, Jano Media, for their support in delivering the Decarb Connect podcast. Over the last few years, they've helped us to facilitate great conversations that connect us with our audience, and their skills and expertise mean that we get to concentrate exclusively on generating the content, the conversations that engage, inform, and inspire. Well, I feel like there's a whole other podcast that should talk to people about what it's like to work in a family business. But luckily for you, that is not this one. We're going to focus on technology, but also this other angle of tapping into the EU Green Industrial Plan. But before we talk about that finance EU piece, can you just give us that layman's overview? So you've mentioned that Brenmiller has this thermal energy storage tech, but just give us a little bit more, and bear in mind that the audience contains people that will probably know a lot and also plenty of people that do not. So a good intro would be helpful, and then we'll talk a little more about the EU.
Yeah, so happy to do that. So basically the concept underneath what we do is quite simple. It is based on studies and things that we know of heating a media. We know maybe how to heat up media in water tanks of hot water. We know rocks in a sauna, which we heat up to create steam. And we do something very similar. So we can look at it as a heat battery, but a high temperature heat battery. We are using crushed, compacted rocks, stones, so it's a physical media to store this heat, but it comes in kind of metal casings, which has also very good qualities of heat transfer and capacity and steam generation, which is very important when you look into these fields. So we heat up this battery up to around 700 degrees C. We can do it by electrically charging our unit from renewable energy from the grid. We can also heat it up directly with different heat at high temperature for coming from combustion of biomass, from waste heat. And then this heat is captured, encapsulated in these modular units. We call them BGENs, or B cubes is the modular unit. We connect them together and we discharge the heat when it is needed. So we completely decouple between when we have available electricity to when do we need the heat. And it's a very important thing because you have renewable power when you have sun or wind, and you need your heat around the clock to your manufacturing plant to work according to what you need for your processes and decouple the two. So this is basically how we do it. We also use media which is very durable, very clean, does not degrade with time, have good cost structure because it's known material you can source almost everywhere and manufacture everywhere. So these are very important parameters when you look for long-term solutions.
Great. Well, I think that's a good intro. We are going to come back later in the conversation to look at a couple of projects and to talk a little more about Brenmiller and the technology. But let's have a look at this kind of funny area, well, thorny area sometimes of the EU's Green Industrial Plan. And I say that because probably for every company that we come across that has been able to benefit from it, there's another company that's utterly befuddled by, how they're going to go about securing that kind of incentive or funding or support. Obviously, you've had some success here. So I wonder if you can just give me your kind of perspective on the EU, the incentives and the support for industrial decarbonisation, and where have you been able to have some success in tapping into it?
Yeah, so there are many types of subsidies that are available for different things. I mean, we have subsidies from or funding coming from European banks to build our manufacturing lines and develop the technology, up to today when we have available subsidies for our projects. Some of them or a lot of them are coming for different innovation or decarbonization funds that are being gathered and collected from different carbon tax or different budgets in Europe, either local in some countries, but also EU, general EU funds like the innovation funds, which can fund capital investment into projects of up to 60 or even more % coverage. These are not very new, but they have been around for a while. But we have seen recently also new type of fundings that are part of maybe as a result of the crisis we saw in Europe and the surge in energy prices in the last couple of years. We see different types of funding, which also helps with the OPEX side. Why is it important? When you look to decarbonize or electrify an industrial process, capital investment is an important part. You want to reduce it. You want to have the subsidies to do it, but you also want to make sure that on ongoing basis, it doesn't cost you more to decarbonize or electrify. You don't want to go and just be green. It's important. It's usually not enough. You want to make sure that you don't only not lose money, but you also gain money from making this transition. Most of the customers want to have at least something which is break even, preferably also saving them something. So if you're competing with an alternative, which is a fossil fuel, which could be at times a low-cost alternative like natural gas in sometimes of the year, then you want to make sure that also your OPEX, your cost of the alternative of the electricity which you are charging, for example, is competitive. And we see programs. We just saw a program going out of Germany a few weeks ago, which is really tapping into this very difficult part of the funding, which is saying to those industrial customers, listen, you'll pay now, let's say, a cent for your kilowatt. It will cost you 1.5 or 2 cents to do it in a green, independent of fossil fuel way. We're gonna fund it. You're gonna calculate it 15 years into the future, and we'll give you the check today to go and build and go to make this transformation. This is a very big change. We haven't seen such programs around the world, although we've seen very big programs in the US coming out recently, etc. This type of funding, which really tackles this part of operational expense of ongoing costs, is something which is relatively new, and I hope other countries will adopt it, because we think it will really accelerate this type of change. And we need many industrial players who are kind of on the verge, thinking we want to do it, but it's more expensive. It will just push them through execution, and I think it's a very big thing. And we are pursuing all of the avenues, both the capex and opex, in the projects that we are developing or where you're selling equipment to.
So one of the things that kind of strikes me as you're talking, like you're quite right, you're talking about these various EU programs, the German program, there's various things that people can tap into, and actually even just keeping track of them is a piece of work in itself. So does that sit with you, or do you have a consultant that you're working with, like literally as a developing family-led business, like how do you keep track of what is possible and what's worth tapping into?
So we started with consultants and firms that helped us, and sometimes it's still needed, because when we go to a new country, we need to understand the local incentives. I have to say that with time, we grew some expertise also in-house on how to do it. So it depends on the program. And you're right, what we know today is maybe different tomorrow. So especially in places like Germany, it's quite complex to understand. So typically we work with local partners and channels to these markets which are local and can understand better, or we bring consultants. And in some cases, we already have to know how in-house to submit. But I would say that there's no one project in this field, I think, today in Europe and probably also in the US, which is not being funded this way or another with one of those state or EU programs. And you're right, it's a lot of know-how. We try to keep ourselves updated, but it also takes sometimes some local expertise to really tap into these funds.
And are you finding that when you initiate a project with a client or a collaborator, are they as aware of the funding opportunities as you, or is almost part of what you're bringing to the table that knowledge that you've developed? How would you describe that kind of balance of knowledge about what's available?
So sometimes they are aware. The more sophisticated ones, which have their own consultants and they're all, so a lot of them are not, or even if they are aware, they don't fully know how to submit applications for these programs. It's not always very easy. We are working on one now. It could be, 50 or 100 pages long, and you need to do different calculations that not all, owners of a plant or workers in a manufacturing plant knows how to do that. And you need to have sometimes the right team members or build a consortium. So there is a lot of know-how. I believe we bring it to the table with us or with partners. We also work with other utilities or developers sometimes to build a fully integrated solution to a customer. Even what we know or do sometimes is not enough. We work, as I said, with large European players to do that. And we bring typically also the ability to submit. Even if the submission has to go out under the customer's name, we help him through the process. We help him understand if he's eligible, what he needs to do to submit, etc. So yeah, I can say it's something that we definitely also bring to the table when we go to a customer.
Okay, and just one last question on this, and then we'll move into talking more about your actual core business. So if you imagine that somewhere out there listening to this is a tech company, maybe 10 years behind, your development cycle, what advice would you give them? Are there sort of one or two things that you're like, yeah, if I went back in time and was at that stage, here's what I'd do, but specifically around this kind of opportunity for incentives or subsidies, what would you say to that up-and-coming tech company?
So I would say two things. First, it's not related to incentives, but sometimes they don't know it's going to take them 10 years. So you need to be patient. You need to understand it's a very long journey. We thought it would take us faster, but in this field, to develop a new technology from scratch and test it and validate it and sell it and commercialize it, it's at least a 10-year cycle. So, and not everybody knows that. So you have to think very clearly how you're going to make this work. You need to make sure that your investors understand what they're getting into. I can say that we have a lot of lessons learned in this field, but the first thing is to know it's going to take a lot of time and money to validate and develop such a technology. So if you want to do something quick, you're in the wrong business. The second thing I would say is that there are different funding incentives that are different for each stage that you need, and you need to understand the mechanism. So a funding program to do a small-scale pilot is one to do a full implementation of industry decarbonization project is something completely different. And you need to understand what's proper for your stage and then try to go for it. We spent some time submitting to something that we didn't have any chance to get because of the level of the maturity of the technology. You need to understand where you are. You need to know who to work with, because we are, for example, a non-European country. So we need to understand when your projects in Europe, how to submit or with who to submit to really get, decent chances to really win these grants and get the projects done. So it's important to try to understand. And if you are not expert, try it at first to get the expertise outside, because knowledge could be a lot of money in this case.
Okay, useful. Thank you for that. Okay, so we will turn back to Brenmiller itself and the technology. So the focus at the moment, and we were talking about this just before we hit record, is on stored temperature ranges up to 700 degrees Celsius. So two questions there. One is, what types of industry or companies does that lend itself to right now? But then the second question is, Decarb Connect, our focus is very much on the harder to abate industrials. So of course our interest is in, and what's it going to take to get that kind of long-term storage of heat up to 1200 degrees or more. So there's two angles to this, I guess, but let's kick off with 700 degrees. Who does this work for right now? And tell us a bit more about that.
Okay, so I mean, one general comment about heat, I think that maybe, a lot of your listeners are aware, and I'm sure you are too, but heat is, of course, a very big part of the puzzle of everything that we as a humanity generate or consume. So over 50% of what you consume goes to thermal energy, and industrial heat is about 25-30% of this heat of the emissions that we generate in the world. So it's a really, really difficult or big part, and it's very difficult to decarbonize all of temperature ranges. So I wouldn't say that today we see a good coverage of heat in any range. Maybe in the low temperature hot water range, let's say up to 100 degrees or so, you have some more known solutions today, like heat pumps, for example. But above that, still the majority of the heat is being generated with fossil fuel boilers, burners, stoves, ovens, etc. So I would say anything about 1 or 150 degrees C today, I see it as difficult to decarbonize, or still very kind of untreated market. We are working mainly on this area of 150 to, let's say, 550 degrees heat, which is we are providing. So again, we need to understand we are storing. Typically, any high temperature storage solution would store temperatures at a certain level and then deliver something a bit lower. The bigger the gap would be between what we are storing, you said 700, for example, in our case, and what we are delivering, the more efficient we would be. We could store more energy in a given volume. So it's important to understand that. It's a bit technical, but it's important to understand it, because even if I can heat up my storage to 1000 to 1200 degrees, if I'm going to deliver the energy at similar temperatures, it's going to be a very inefficient process. To do it efficiently, I'm going to need to heat up my storage to 1500 degrees, for example. But my point is, first, there is a lot of customers in the field of medium temperature, what I mentioned, 150 to 500, 550, chemicals, food, tobacco, refining, are all in this field of operating on saturated steam or steam at temperatures that I mentioned. The harder part is, as you mentioned, above that. It's hard because it's high temperatures, because you have to create a system which is both durable in terms of materials, but also for a long period of time. You don't want to install something, heat it up to a very high temperature, and then have it completely eroded after 2 years. So this is a challenge in terms of materials. I can say that we are working today on the next stage of 1,000 degrees, and I believe we'll get there. But it is challenging both on the technology side. But again, I think the market that I mentioned is very strong today for us. Many companies in this field of medium temperature are looking for decarbonizers to replace their heat boilers, and the next step will be, as you mentioned, to go to cement, to steel, to glass, to places which do need higher temperatures. But I'm just saying we have a lot of work to be done even before we go to these temperature ranges.
And I'm assuming, kind of guessing, that it's not just a case of, it's actually, so it starts being a different process once you're getting to that level of heat. Is that true? Like, rather than just scaling up what you have now, and literally in terms of space or something like that, is it a different process that would need to go through?
It would be in this type of high temperatures, would be probably a different storage media. It's not just the media, the storage, there's an entire system around it. It needs to be endured and handle high temperatures, getting them in the heat, getting out the heat. You have to find resistive heaters or electrical heaters that can restore these very high temperatures over long cycles. So there is a lot of development. You need to use, as I said, the more expensive, more unique materials, and have probably a higher erosion. So there are challenges there. It is challenging. It will cost more. The systems will be more expensive to get to these temperatures. And again, you have to remember, you can't be too expensive. As I said, we have to compete with some alternative, which is out there producing their heat today. So I would still say I believe it will still be challenging in the near term. The technology will get there eventually, and as we gain more and more experience also with medium or high medium temperatures, we'll build up the experience and the know-how also to go and increase all the time our temperatures.
Okay. Well, just sort of building on the marketplace that you were just talking about there. So you referenced refining, food, chemicals, obviously on your website, and we were talking again off air that you've had projects in place with power generation companies as well. So EU market, I guess, must be a pretty good market to be in at the moment, in part due to this kind of higher energy prices that we've been seeing. And certainly, I guess people are still talking about energy insecurity. It seemed to be the theme of last year. So what are the main kind of groups that you really see reaching out to you at the moment? Is it, that power gen utilities piece, or is it, all sorts, just depending where they are in their own journey around CO2 reduction?
So we are seeing, again, two types. We are working in two spaces, the industrial space and the utilities space. So in the utility space, we do different solutions for large thermal power plants. We have a project like that with ENEL in Italy to decarbonize or make thermal generation more flexible. But we are doing another thing with these type of utilities, because many of the utilities like ENEL are also big renewable developers, which have their own large set of industrial customers. And also, as I mentioned before, we are partnering with them to offer a full solution for the industrial clients. And the industrial clients that are looking for such solutions. So in the past, it used to be more the ones that are really looking at their ESG goals and marks and have very strong and active investors who wants them to go clean and green. But recently, because of, as you mentioned, the rising energy cost and also the uncertainty. So maybe the costs are going down now, but the uncertainty and what they experienced in the last 2 years really left a mark. And they're looking to be less dependent on fossil fuels that someone could shut down, and also less dependent on the volatility of these prices. And by, for example, electrifying heat with a renewable source, you actually hedge your energy costs. So you can get not just clean green power, you also get some understanding of your energy cost, 20, 30 years going forward. So we see it not just being those clients which are, in the top 10th of being, ESG, followers. We see many that are also looking at as an alternative solution for fuels in terms of economics and in terms of hedging your risk. And we are working either directly with these customers or, as I said, with our utility partners that are going with us and offering a full package with thermal storage, with the PV field or wind farm, or just green electricity they can bring from their renewable assets. Maybe in some cases they also install other equipment like a heat pump or a battery to bring a full solution. But really, we are usually a key part of this solution, as industrial heat is typically could be 50 or 70% of the energy consumption of those industrial players.
Okay, so kind of useful to hear that, I think, about where you play in those two adjacent but different kind of markets. It's one of the things that was interesting, I think, learning about Brenmiller is I mean, you said earlier people need to understand it's a journey and it's 10 years plus, but 10 years plus on from when you founded, you Nasdaq listed and have your first gigafactory opening by the end of this year. I wonder what have you learned from that development process? Because there's a cycle of growth in a startup through to scale up through to gigafactory builder. I mean, that's quite a step change. So what have you learned from that particular part of the journey and the process so far?
So as I said, the journey is already quite long, and we started from a startup to a company which is a public company, first in Israel, then in the Nasdaq. I believe we are still, a young company in the life of such industries. But getting, I think, to commercialization is, as I said, a long path, because sometimes we believe that demonstrating a technology is enough. So you demonstrate it in a certain scale, and then you have to scale it up. And then you have to find usually more than one customers which are willing to test your technology and validate it. And it took us, for example, in the project I mentioned in Italy with ENEL, about 3 years process to get them on board to do the first installation. The second one is already easier. And the same thing goes into the product development lifecycle. So you start in your lab, you do some experiments, you get some results, you say, okay, looks okay. Then we did, I think, 4 or 5 generations of demonstrations until we got to a scale when we could convince someone to finance, an external project, or even project we could give for free to a customer for him to run, because you have to understand these customers are very conservative with their energy. They don't want you to experiment on them and interrupt with the processes. So you have to be quite solidly proven before they will allow you in their backyard. So we had to go through the development of the product to test it over a few generations. And then you have also to be ready to manufacture at scale, because once they see it working, they want to make sure that you can go at the scale that they need, even if you have 20 or 50 or 100 projects at the same time. So the scale that we built now, a 4 gigawatt hour scale, I can say is a good scale, but even that is not sufficient for a future problem. It's just the first manufacturing plant that we did. And these clients wants to see the scale. You also need to do automation to get to the price that you want, because okay, you can do a first installation by building them quickly in-house. It's going to cost more, but you say it's okay, it's the first or second time I do that, the costs are not critical. But we are a public company, the costs and the revenues and the profits is important. So we also have to scale up and go down the cost reduction curve. So it's not enough to say, it's going to cost me 1,000 today, but I will believe I'll be at 50 5 years from now. You really need to start making the steps to make it happen. Otherwise, there's a very big a gap along the way that you can, fail. So I think it's very important to have those things progress, at the same time, both on automating your product and of course making it work, and also building the company in a way that has strong financial background. The companies you're selling to, those industrial facilities, want to make sure that you'll be around also in 3 and 5 and 10 years from now, because they are dependent on you. It's new for them. They don't have 10 other suppliers which can come in, step in, and make it work. So all of these things are real barriers, I would say, in our field to make the journey from a nice startup into actually commercial commercially viable technology.
Yeah. I think an interesting question as to you studied an MBA, but it feels like you've lived an MBA as well through that whole whole series of events. So where, out of interest, where is that gigafactory going to be built? Is it kind of close to European customers? Is it in Israel? Is it somewhere else? Where are you planning for that?
So the first one is already built and operational. We just inaugurated a couple of months ago in Israel. It was funded by the European Investment Bank. So I think we are the first company in our field to actually have, there are a lot of announcements, but actually that built and are now operating a gigawatt-hour facility. And as I said, it's the first one, honestly. We're located in Israel because we wanted the first one to be close to home for us to be able to, make sure that it's close to us to work on and make sure it works properly. And also because our project was kind of scattered. So we had projects in Brazil, in Europe, in the US. So we said, okay, it's not enough pipeline in each country to build their manufacturing plant. But the plan is the next production plants, which are planned to be rolled out in the next years, not 5 or 10 years. In the next year or two, I believe we'll have another line, are where the projects are going to be. We want to make sure it's close to the projects or to the raw materials. These things that we are building are heavy. We want to minimize transportation. We want to provide local jobs also where the projects are, where the subsidies are coming from. In many subsidies, it's a condition to receive the full grants. So I would envision that the next facility we'll see will probably be in Europe, the way that we look at our projects pipeline now. Later on, we also see them in South America and in the US. This is how I believe we will see it, but the first one is already working here in Israel.
Great. Okay, well, let's now take a look at one of the projects. Up to you. You can choose. Is it going to be that, I know we talked about the one called Tempo, which is in your pipeline at the moment, or whether you prefer to talk about FortLev or the ENEL project, but let's have a look at how that came together. And one of the things that a lot of our industrials are always interested in are some of the physical elements of these projects, like literally how much space they take up, let alone what they do for them. So whichever project you'd like to choose, I'll leave with you, but tell us a little bit about it and the kind of the physical elements of it as much as the kind of conceptual elements of the technology.
Okay, so I would just mention, I think, the projects that we have in Brazil and Italy as a good reference cases to thermal storage, because again, there are not too many projects around the world today that are working with these new generation of technology. So I think there are 24 megawatt hour storage connected to a 400 megawatt steam plant or combined cycle in Italy is a very good showcase to show full scale. And this is important, by the way, also for industrial players, even if it's not in an industrial setting, because they want to come. I go there every 2 weeks. Someone wants to come and kick the tires. So I'm not going too deeply on this application, but I think it's an important project. Also, the one we have in Brazil is an industrial project. We are supplying hot air to a plastic factory. And in this case, we're using biomass as the source to charge. But I would focus more on projects like Tempo, because it's a very good, I think, example of what is the main type of solution we see today and what our main pipeline is built off. It's a project of electrification of heat. Now, these projects have a few elements to them. Typically, if you look just at the storage part and related components or auxiliaries, it doesn't consume a lot of space. It depends on the size of the project. Some customers need 5 tons of steam, some need 50, some need 500. So we need to see what's the need. But we are trying to build something which is quite compact. Unlike a chemical battery, which is usually installed in scattered areas in containers, we can stack up our unit. So in, let's say, a footprint of 15 by 15 meters, and up to 20 or so meters, we can go to 500 megawatt hour storage capacity. And then you will have some 3-4 containers, 40-foot containers for electrical equipment, and some water tanks that could be part of the project or not, depends what the customer have, but not something which takes a lot of space. So it will be anything from a small project, which is kind of let's say one 40-foot container, up to something in this case that I said, a 15 by 15 meters, which typically we are able to find, because also the larger facilities are typically located in areas when you have more available space. What is sometimes challenging is if you want to build also a completely off-grid or project which is fed from renewables. Then if you want to put a 500 megawatt hour system also with a 300 megawatt PV field, which is a new build or greenfield project, you need more space. So in some place it makes sense to have it, near the customer site. If you can we can secure the land. In others, we'll have it remotely or we'll charge from the grid. Which is also a good solution. I don't think we mentioned it, but another thing that we can do with the thermal storage is not just provide clean steam to a customer. It's also to provide different grid services using this facility. And recently in Europe, also regulation changed. And today, a thermal energy storage can play a different role in grid services in areas that has congestion because of excess renewables, and can also supply the services of reducing or increasing load on the grid in some hours. Why do the industrial customer cares? Because when I supply more services to the grid, I get more revenues. When I get more revenues, he can get a nice discount also on his energy cost when he's buying energy from me, or also when he's buying the equipment, he can also play in the market and get a few revenue streams. And this is also, I think, is a game changer. So we can either charge from the grid, we can also charge from storage. What we do in the Tempo case is we charge from the grid. In this case, there's no space. We do have some rooftop PV we are also utilizing, but most of the energy comes from the grid. They are using heavy fuel today for their drinks, for the production of their drinks. They are the biggest beverage manufacturer in Israel. They are partly owned by Heineken, the global Heineken. And in Israel, you do have, I would say, quite a low-cost natural gas, but they don't have access to it because they're not part of the grid. So they're a good candidate that are using quite an expensive polluting fuel. They are also part of Heineken, so they have their own ESG rules they have to adhere to. And there we are fully electrifying their steam. So we're replacing almost the 14-ton boilers, heavy fuel boilers, with our solution, charging it from electricity and providing this clean heat. And it's about 32 megawatt hour system, which is a nice scale with 14-ton peaks. And I think it will be also a very nice demonstration. We are supplying medium temperature. Again, most of those type of customers needs steam at 180, 200, up to 300 degrees. These is most of the cases that we see. So this is the use case, and like this we have many more, mainly in Europe, in Spain, in Germany, and I think the last months we've seen an increasingly growing number of leads and companies coming to us looking for just this type of solution.
And you mentioned that for the Brazilian project, the energy source is biomass. How does that change the dynamics of the project, or how does that change, the kind of I guess the project setup, project management?
Well, so that makes the problem a bit more complex. I mean, the energy storage part is quite similar, but you have additional components that are used to combust the biomass, clean the gases of the biomass. We cannot work with very clean gas biomass coming into the storage. It will damage the piping, will clog the piping. So the gases have to be cleaned. So we burn a certain type of fuel. We need to understand what biomass source we have wherever we have it. Charge the unit. The advantage of using a storage in this setting is that the biomass is a very constant process. You can't keep turning off and on the biomass burners. It's not very inefficient. And many processes are not continuous. Also, the project we have in Brazil, they require different cycles of heat for their melting of their plastic molds, and they cannot go to standard biomass equipment. So you have to use natural gas, which is quite expensive in Brazil. So we installed the biomass equipment together with a solution. As I said, here the biomass also could take a certain footprint, which is typically even 2 times more than the storage itself. Again, it depends on the size. And in areas when you do have low-cost biomass, which is, I would say, high quality, you don't want to burn anything because then you will emit and you want to meet the standards. it could make sense. We think it's a good solution, but I have to say that I think the more accessible solution, which is, could be implemented anywhere in any environment, and less dependent on a source of fuel which is changing, like biomass, is electrification. But I think still it could be a good option to ones that are looking to use heat either in the form of combustion biomass, also in certain cases in recovering heat from existing industrial procedures, which is also something which is relevant for many industries, a bit more complex. Again, I mean, recovering heat sounds like a very low-hanging fruit, but it's not easy. It's not easy. Sometimes the heat you're recovering is dirty. Sometimes it's not at temperatures that are high enough for you to make something useful using thermal storage. So it's something to look at, but it's less, I would say, straightforward from just electrifying this process.
And would you say, just thinking about those different types of projects you talked about, I guess the drivers must change between companies, but are people mostly engaging with you because of a solution to intermittent power or something, or are they mostly engaging around their own, I don't know, like a cleaner power that you can help provide, more constant? Like is there one driver above all, or is it, as possibly it sounds like, actually it just depends on the company about why this makes sense to them?
Most companies, they don't exactly know how to do what they want to do. So they know that where their energy bills are coming from, and they say, listen, look at my gas bill. Okay, so I know my electricity bill. I put PV on the roof. Maybe I put a small battery. I replaced all my lighting, so I'm very efficient on the electrical side. Great. Now 60-70 remaining percentage comes from, let's say, heating and cooling. I have very good chillers, so I'm good on cooling. Let's see what I'll do with my boilers. And then they start to look what are the alternatives for clean steam or clean heat. And in this point, usually they are coming either to the more known, I would say, around technologies like electrical boiler. Again, I'm talking about our temperature ranges. In the low temperatures, there's also heat pumps. A lot of them like to talk about green hydrogen, but I think it's still not an available solution today. So they're talking about a lot, but I don't think it's relevant for providing affordable, clean steam today. And then they come to us or to our competitors and say, okay, we want something which will be cost effective, green as much as possible, if not 100%, and available when we need it. We can't have something which is just available when the prices are low. For when an e-boiler operates online, you cannot charge when it's low and provide the energy afterwards, and we can do it. So these combinations of green, reliable, independent source with also something which doesn't cost me more, preferably less, is, I think, the more, if I would summarize, the 3-4 main criteria that these type of companies are usually looking for.
Yeah. Okay. Well, just sort of to begin wrapping up the conversation, and I know you've mentioned that you're now a listed company. What's next for you? What's next for you and the company? And what are you looking for, other forms of financing at the moment, or I don't know? Yeah, tell us a bit about what's coming next for you in your development cycle.
So I think, we are a listed company. We just recently listed on Nasdaq, and the plan is to use this listing on Nasdaq to support our growth. When I say growth, not necessarily mean the growth of the project. We are also looking on the project side to go to energy as a service model. And in this case, we are forming partnership either with leading developers. I mentioned ENEL as one, and there are others. We are building our own local entities in each major market, in Europe and later on in the US and others. So we are building the local entities. We plan to bring for these local entities funding in the form of funding for the projects we will bring to the table in terms of projects that will be kind of development of energy as a service projects. And of course, we intend to continue and develop the company in Nasdaq, use it to reach more investors in this field, bring partners both on the project level, but also into the company if they bring us the right value to grow the company, because we are now in a path that we feel is about to significantly grow in the next year or two. And growth usually comes with a lot of needs in terms of resources, both on the project level, country level, and also on the corporate level.
Well, it's been I suppose at times it must feel like a long 10 years, but as an outsider listening to the story, it sort of feels like there's been such a pace of activity during that time that's led you up to this point. Yeah, really fascinating.
It's a roller coaster. It didn't take 10 years because we moved slow. It took 10 years because
you got it right.
As they said, yeah, to get it right, to get it to work, to get the markets to trust you, and it was a very intense 10 years. But we are, happy with what we are doing. We really feel a sense of, efficient. We are really happy that the market is also getting there, because we could have developed this in 10 years and the market could have gone the other way. I think, the fact that organizations like you exist is nothing, it's not trivial, because a few years ago, nobody heard about heat and about this field, and today there's a lot of hassle around that, and it's really in good timing for us, as we are ready with the product, ready with the manufacturing, and now the market is getting there. So I think also timing in life is important, and we feel that we are in the right timing.
Absolutely. Well, thank you, Doron. I really appreciate you spending some time talking that through. And yeah, always interesting to hear about. We spend a lot of time really talking to companies probably at a slightly earlier stage, if anything, than where you are. So it's great to have that example that both our industrials, investors, other people of interest in in the industry, but also those earlier stage technology companies can really hear, okay, just buckle up. It is going to be 10 years plus, but it's possible. So thank you very much.
Thank you very much, Alex, for having me and for your time.
At Jano Media, we recognise that great content has the power to create impactful and positive change for lives and society. Whether that's video, live streams, photography or podcasts, partnering with us will enable you to harness the power of content to engage, inform, and inspire. Reach out to us today.